Hi, this is Mr. V, and you have survived the first quarter of pre-algebra. I really hope you're excited about that because now we're done. We're done dealing with integers. We're done with dealing with natural. No, we're not. That's actually a lie. That's a really big lie. Actually, we are going to be taking all those great things that we learned in the first quarter, solving equations, how to multiply integers, how to add integers. We're going to use all of that stuff now, and we're actually going to apply it to other things other than just equations. The first quarter I summarize as it is about equations. The second quarter, I honestly believe this is it. It's all about the exponents. Right here, right now. It is about exponents, hands down. And that to me is awesome because we get to use all the stuff that we've learned and we actually get to apply it to something that's new. That, well, it's not necessarily new, right? Like, we know what exponents are. It's just using them in a different way and coming to terms with that and even coming up with a few new ideas. One new thing is also a new operation. Man, that's not for another 4 or 5 videos. First off, let's just make sure we really understand what an exponent is, and I'm going to show 2 examples that trip people up even in 8th grade. So I really want to address them this video right now. Here we go. I've got my tool bag with some vocabulary in it. Please write it down. Just a little bit of a reminder what a natural number is. A natural number is like 1, 2, 3, on forever. Not negatives, not 0. Negatives and zeros are not natural numbers. It's just 1, 2, 3, on. So I just wanted to give you a reminder about that because we are dealing with exponents that are only natural numbers. Do you think we're going to do something with integer exponents? It's next video. Yeah, I know. Exciting, right? I'm excited. Okay, so we're going to talk about exponents, what is exponential form, base, and a power. Oh, I did forget to write one thing down, and this is called expanded notation. And we're actually going to do that right now. So let's look at our first example. Here we go. 4/3. What is 4/3? Well, 4/3 is, that's right here, this is it. It is exponential form. We have a base. Oh, there's that word base right there. And then there's the exponent. So exponential form has taken a base and raised it to an exponent. Okay. Well, you might be asking yourself, that's going to be pretty confusing, Mr. V. What do you recommend? I recommend, as always, whipping out the good old-fashioned color pencils. I've got this, I really don't know how to pronounce that. Orchard color? What is orchard? Never mind. And then I've got a light brown. Whatever. Use 2 different colors. I'm going to write down the 4 in this color and then the 3 in this color. That looks kind of different. Sure, whatever. Just because I want the base to be one color and I want the exponent to be a different color. So right now this is exponential form. What am I going to do? I've got an equal sign. Oh, here we go. Balance line. Just to make things look nice and neat, the balance line just lines up the equal sign and it just helps to make it look good. So now we are in exponential form. We need to turn it into expanded notation. Mr. V, what's expanded notation? All that is 4 times 4 times 4. That is expanded notation. It's taking the base 4 and multiplying it to itself 3 times. So the base is the number I'm going to write over and over again. The exponent is telling me how many times to multiply the number over and over again. Okay? So, quick thing, this is exponential form. So if it ever says give an answer in exponential form, that's this. Exponential form, write that down. Heck, I'll even do it. I'll even put an arrow. Exponential form. This is expanded notation. Okay. Now, if it says to simplify or to just give it find the power, what's the power? The power is the final answer. It's just a fancy way of saying it. Well, let's just do it. I know 4 times 4 is 16 times 4. Remember, I'm multiplying these two together. Okay? And 16 times 4 is 6 times 4 is 24. Drop to 4 down. Carry to 2. 1 times 4 is 4 plus 2, 64. 64 is the power. So, depending on what they ask you for, they might give this to you, the power, and say, write it in exponential form. Or they might say, write the exponential form in expanded notation. Or they'll say, write the expanded notation in exponential form. There are a lot of different questions I could ask. You really need to know the difference between exponential form, expanded notation, and power. 3 very simple things. You know, you've been doing this. We've already been doing this a little bit the first quarter, but now I'm actually giving it a name. This is a power. This is expanded notation. This is exponential form. Good times. Example number 2. Oh yeah, let's do it. -2 in parentheses, and those parentheses are a big deal, and you'll see that in example number 3. -2 raised to the 5th power. Well, I'm going to rewrite this. So I'm rewriting, as always, my first step. And I'm putting parentheses in pencil. The base, I'm going to put, well, that's -2 in one color. The exponent in a different color. What did we just write down? Well, this is, again, this is the exponential form. Okay? I'm going to balance line. So I give this to you in exponential form. I'm going to ask you, what is the power? Well, the power is we have to expand it out. We have to rewrite it in expanded notation. -2 times -2 times -2. And how many times am I going to write this? How about 5, since that's my exponent? So, tilt this down a little bit. Perfect. And a little more. There we go. Looking good, looking good. Okay. So now what do I have? Well, now I have my expanded exponential form. Now I have it in expanded notation. Now, I could take my time and go -2 times -2 is 4. 4 times -2 is -8, which is fine if you want to do it that way. We have all these awesome properties now. I'm going to use the associative property and multiply out of order. Like -2 and -2, that makes, well, negative times a negative is a +4. Okay, so that's those two. Times -2 times -2 is +4 times, and we got that last little -2 hanging out by himself. Remember, we can do that using the property associative property. The associative property of multiplication, remember you want to say multiplication, it lets us multiply more than one thing at one time, which is really helpful to speed things up. Well, 4 times 4, hey, didn't we just do that up there? We did. 4 times 4 is 16. +16 times -2. Oh, first question is negative times a positive is a negative. And 16 times 2 is 32. Oh, and I didn't do it up there, but I'm going to do this down here. So that means -2 raised to the 5th power is equal to -32. And that's it. And again, remember, this is the power. So in the warm-up, I could possibly give you 3 boxes, and one would say, what is the expanded form? What is the power? What is the exponential form? Those 3 questions, totally possible on a test. So you really want to know which one's which. Okay? So that's example number 1 and 2. Let's do another example. So, well, by the way, this one turned out to be a negative power. Oh, a negative raised to a power turned out to be negative. I wonder if that always happens. Why don't we check it out? Don't worry about that. That's example number 4. Example number 3. Well, I have negative 6 squared negative 6 squared. This is my exponential form. And now I'm going to write it in expanded form. I write it twice because of the exponent. Well, now I'm just going to multiply. Negative times a negative is a positive, so 6 times 6 is 36. That's it. Hey, done. So, now we have an interesting case. Negative 6 in parentheses, and that's a big deal. Get ready for example number 4. Negative 6 in parentheses squared equal to positive. If you think about it, there's a little tiny rule. If it's in parentheses and it's an even power or an even exponent, the power will be positive. If it's a negative base, oh, by the way, yeah, it's a negative base. Remember, number that's being raised or written more and more, that's a base. If it's a negative base raised to an odd exponent, the answer will be negative. That's a little tiny rule, and we'll work more on that just next time. But that's just a little tip. And it doesn't even have to be a rule. When you work it out, you find out that that's true anyways, if you do it correctly. Mr. V, you mentioned in this parentheses. What if there ain't no parentheses? That's a very well put question, because ain't is a word according to Webster. Negative 7 to the 3rd power. Well, negative isn't in parentheses now. So my first thought is this. The negative is not in parentheses. That's not, if it's not in parentheses, I'm not going to write negative 7 3 times. In fact, I'm going to put the negative out here. And I'm going to write 7 to the 3rd power. I'm going to actually redo this a little bit because it's a little tacky. It actually looks like this. So it's actually the base 7. Darken up a little bit. Come on, killing me. It's actually the base 7 raised to the 3rd power and then turned into a negative. So no matter what, this thing out here is going to turn this into a negative. This is always a negative answer. In the discussion, if there's no parentheses, it's automatically going to be negative no matter what. I'm going to turn this into expanded form. 7 times 7 times 7. The exponent tells me to write the base 3 times. Well, 7 times 7 is 49. See, 6 times 9, or sorry, 9 times 7 is 36. Carry to 6. 4 times 7 is 28. 28 plus 6 is 34. And by the way, here's one of the properties. This is the multiplicative identity. I did say it right. There's no number in front of there. It's just a negative. Think back to with the equations and inequalities, because I brought this up also. If there's no number, I can always put a 1 right here. 1 times anything is 3. 1 times 343, that's 343. but a negative times a positive is definitely a negative. So with parentheses and without parentheses, kind of a little tricky. This will always be negative. If there's no parentheses, it will always be negative. But if it does have parentheses, it depends. If the exponent is even, it'll be positive. If the exponent is odd, it'll be negative. So, something to think about and definitely be aware of. Okay, well, that is it for this lesson. That's exponents. Basically, most of it you know. The negatives do, it's negative time. Welcome to 7th grade. We're going to talk about the negatives. So, be ready for that and be ready for the next video. Have a great evening.